Our industry is no stranger to regulations, and even though HFCs were considered to be the long-term replacement for ozone-depleting CFCs and HCFCs, the regulatory freight train continues to impact our industry. When we consider what refrigerants and equipment choices we have today, it's helpful to understand that our choices are influenced not just by the application, but also by EPA regulations that phased out the production of great refrigerants like R-22, as well as regulations designed to drive down the use of higher global warming HFC refrigerants like R-404A in the future. Also keep in mind that the DOE keeps imposing higher efficiency requirements for equipment, and that building codes must be updated to allow for the use of the new lower GWP refrigerants being approved by the EPA. We're going to take a couple minutes to talk about some of the upcoming regulatory actions so that you are aware that refrigerant choices for products other than R-22 will need to be considered in the future. The Kigali Amendment has been ratified by at least 115 countries. While the process of U.S. ratification continues, Congress passed the AIM Act, the American Innovation and Manufacturing Act, in late December 2020. The AIM Act mirrors the Kigali HFC phase-down schedule and includes provisions for sector-based use controls, as well as refrigerant management. Allocations will be issued on a CO2 equivalent basis of the global warming potential of refrigerants, so it will not be refrigerant specific. This method will allow companies to produce and import the refrigerants needed as the industry transitions to lower global warming potential refrigerants over the next decade. Sector-based controls are being driven mainly by OEMs. They want certainty in how to design their equipment. So instead of letting the EPA dictate that, they feel it is in their best interest to ask the EPA for certain GWP limits on new refrigeration and air conditioning equipment. Another sector-based control that is anticipated will reinstate the SNAP 20 and 21 refrigerant restrictions. It's not clear when this would take effect, maybe in January 2023, but the EPA has 6 months to grant or deny any petition, then 2 years after that to finalize a regulation. It is important to keep in mind that the AIM Act does not affect the servicing of the installed base of equipment. EPA regulations have always had the goal to make sure that equipment is not stranded in the field. This is the phase-down schedule. Developed countries who ratified Kigali began their phase-down in 2019. The US will start our phase-down January 1 of 2022. As you can see, we will start at 90% of the US baseline, currently estimated to be about 300 million metric tons of CO2 equivalent. The EPA will finalize the baseline in September. The next reduction of 40% will come in 2024, just a couple years later. In 2029, will be further reduced to 30% of the baseline, with the final planned reduction occurring in 2036, leveling off at 15% of the baseline. So as you can see, the HFC reduction is a phase down, not a phase out, and there will always be some quantity of HFCs permitted to be produced or imported. In the absence of federal regulations and the reversal of SNAP 20 and 21 restrictions, individual states took it upon themselves to adopt the SNAP restrictions as state law. As you can see on this chart, 9 states already have or will have restrictions in place this year. This is why we need the AIM Act. States will be able to rely on federal regulations and not have to put their own restrictions in place. This will make it much easier for contractors and equipment owners to comply. Retail food refrigeration is the first sector affected. Take note of the 7 states with an asterisk. Those states have adopted a definition of new equipment that was not part of the federal SNAP rules. Generally speaking, while you are free to repair systems and replace components as needed, in these 7 states, you will need to be aware that doing so may equate to being considered a new system, and consequently, repairs may not be allowed. For more information about this, please go to United's website and click on the Refrigerant Regulatory Updates link. That will take you to a summary of what each state and the definition of new. We've all seen this chart before, or at least one similar. We now have a full year behind us where no new R-22 has been introduced to the market. No import of R-22 or manufacturing in the US. We found very strong demand for R-22 in 2020, in part due to the lack of retrofit and more repair versus the replacement of systems. This means that there is less R-22 available now for folks who cannot or do not want to move out of R-22. As the laws of supply and demand state, if supply is dwindling and the demand is strong, the price will continue to move up to create balance. We are strongly advocating that customers who can retrofit out of R-22 do so as soon as the opportunity presents itself. Let's review some of those scenarios and considerations now. With that, I turn the presentation over to Russ Barnhouse. Thank you.
Thank you, Joe, and good morning or afternoon, everyone, depending on your location. I appreciate everyone signing in here for us to give this information. And as you can see, we're talking about primarily R-22 today, but Joe presented information that will affect other refrigerants that are HFCs. Of course, R-22 being an HCFC, the phase down or phase out of R-22 is part of the original Montreal Protocol and the Clean Air Act. So we're now finishing up that from 30 years ago, but 22 is, we are finally kind of reaching that end state here for R-22. So what I plan to talk to you about through the rest of the presentation here is really more of the technical side of these refrigerants alternatives and what steps would need to be taken to convert that system that you have out in the field at this point. So let's talk for a minute about when to maintain a system. So when would you want to leave your system in R-22? And if you have a system that's been performing well with no leaks or very limited leaks, then there really isn't a motivation necessarily to convert it. Again, R-22 is a good refrigerant. One motivation might be if you had other equipment that was running on 22 and you wanted to convert some and bank that gas for future use. We'll talk about that later, but that might be a reason you take out, you convert a system that's been performing well. If you have a system where there's no good retrofit options, either due to the design of the system or just the sheer cost to retrofit, you may want to keep that system in R-22. However, performing thorough leak checks and making sure you're not leaking refrigerant would obviously be an important thing to do with those systems. And then if there's just not a cost justification, so if you have a very small charge size, or equipment that will be replaced soon, these might be reasons why you would leave the system in R-22. So if you're going to maintain with R-22, there's some best practices you should follow. And first of those would be, as I mentioned before, perform thorough leak checks and repair all the leaks. It's important that we preserve that R-22 supply. Another piece of this that goes towards preserving the R-22 that's installed at this point is to make sure you do not top off alternative refrigerants on top of R-22. You'll see in some literature on alternative refrigerants where it discusses things as this refrigerant can be topped off. What that means is that you can put that alternative on top of it. If you've already converted the system, you need to top the system up and add a few more pounds of the alternative. You can go ahead and do that, but never mix gas. Mixing refrigerants, once you've mixed alternative refrigerants into R-22, first off, you don't know what the system will do, and technically it's not a legal thing to do. But also what's happened is that R-22 becomes contaminated and mixed, and it's very difficult to separate those. It's expensive to separate those. And in fact, if you bring back a recovery tank with mixed gas in it, you're going to be charged by the wholesaler a price per pound for returning mixed gas. And so because we have a certain amount of R-22 still left in systems out there, we have no new production. What we have either in leftover stockpiles or what comes back on reclaim is going to be the source of R-22 in the future, and that needs to be preserved. And finally here, it's smart to use a banking program such as National Refrigerants Reclaimed Refrigerant Banking Program. Essentially, you can sign up for a bank account and you can bank that refrigerant with National, and United Refrigeration is the agent for that. So any United Refrigeration location, you could withdraw the gas that you have banked. And that's not just limited R-22. There's a long list of refrigerants that are eligible to be banked. So as we go forward, this banking program is going to be very important. Now, a few things to consider. One is that the banked gas has to be returned in a 125 cylinder or larger. At this time, we don't take cylinders of 30 or 50 pounds for the banked just because of the logistics of handling that. And it takes a certain amount of gas to open the bank deposit. So those details are on the NRI website at refrigerants.com if you are interested in that, or reach out to your local United. When we start switching to, switching gears here, going to retrofit, and when is the time to retrofit? Now is the time to retrofit. So the supply of 22 has dwindled to a point where you're now seeing significant price increases in the market. Also, just possibly some maybe completely out of R-22. So we've kind of reached that point where we really have to start considering retrofitting due to availability and price. And so a good time to retrofit would be when a compressor is replaced. So anytime you're replacing the compressor, that's a great time to convert the system. And the reason for that is that the new compressors come with POE in the compressor. Now, that would be for a hermetic compressor or a scroll type compressor. For semi-hermetic compressors that have an oil drain plug, those typically come dry without oil in them. But again, you're able to convert the system at that time. And really going back to say 2013, all these compressors were starting to be supplied with POE oil in them. And we'll talk a little bit later why oil is important. If you have simple access to an oil change, so you do have a semi-hermetic compressor with an oil plug in it, and you can drain that oil, it's a great way to go in and get the oil out to do a conversion. If you've had a large refrigerant loss and you've lost a lot of R-22, again, the price of 22 is high now. And so it would be a good time to invest that money into a conversion as opposed to buying the R-22 that it would take to refill the system. One thing to keep in mind is there are some possible trade-offs when it comes to system performance when you go to an alternative refrigerant. And we'll discuss those as we go further into this talk so that everyone understands what to expect when converting those systems. So what are the factors in deciding what refrigerant you should pick for an alternative? And there's a number of things I have on the screen here: a pressure temperature match, similar pressures to R-22, what is the oil compatibility, what happens to the capacity of the system, what is the flow rate of the refrigerant that goes through the piping and the components, energy efficiency, what is the availability of that alternative refrigerant if you need to get it down the road. And then of course there's cost. There's cost of the refrigerant and there's cost that it takes to convert that system. And so if we break down these alternatives really into two categories, and these two categories are refrigerants that are only compatible with mineral oil or refrigerants that are compatible with mineral oil, alkylbenzene oil. Now those alternative refrigerants will also be compatible with POE oil, but often if you do not have easy access to drain the oil out of the compressor and to make an oil change, contractors will choose to use a refrigerant that is compatible with the older mineral and alkylbenzene type oils that are in the older equipment. those refrigerants contain a hydrocarbon or some other type of oil additive that helps get the oil to flow through the system along with that alternative refrigerant. And because of that additive and the characteristics of these alternatives, you may see some capacity drop. And that capacity drop will vary depending on the application of the equipment. We can get into that a little bit further as we go, but the capacity drop in many cases may not even be noticed because it's a slight capacity drop. If you have a receiver or a complicated piping, then that might be a system you may not want to convert to a refrigerant that's compatible with these oils. You may want to go to a refrigerant that is compatible with POE, which I'll explain in a minute, and I'll get a little bit more into why with a receiver you may want to go to a POE compatible oil. So when we talk about the refrigerants that are POE oil only compatible, these are HFCs or HFOs. So HFOs, that's a new molecule that has a lower GWP. And so the HFO molecules have been mixed with HFCs to create blends that are lower GWP. And I'll explain that a little bit further when we go ahead. But the HFC does not have a chlorine component to it. And that chlorine is what mixed well with the mineral and alkyl benzene oil and carried it through the system. So those systems require a different oil type, which is POE oil. And POE oil will mix well with your mineral oil or alkyl benzene oil. And we're often today seeing the POE oil in mixtures with mineral oil at concentrations higher than 5% residual mineral oil. So originally, some of the compressor manufacturers came out and said you can have no more than 5% residual mineral oil. We're seeing conversions today where those guidelines have been raised, and even as high as 10% residual in mineral oil. Now, of course, we want you to follow the compressor manufacturer's recommendations, particularly for in-warranty systems, but I thought I would share that we are seeing some success at slightly higher residual mineral oil. And you'll get very little to no capacity drop in the system when you pick an HFC refrigerant, which gives you some peace of mind, and the oil flow characteristics are very good. So what gets oil to circulate? And I have this picture of the beaker just showing an example of immiscible fluids. So fluids where they don't mix well. And that's the challenge that we have with mineral oil and the HFC refrigerants, that they don't mix well in solution. So what they can do is leave oil left in the receiver. And so the mixability of that oil is what allows the refrigerant and oil mixture to come out of a liquid receiver. When you have suction risers where you're going up vertical piping, velocity is what carries that oil back up to the compressors. And if you had long horizontal suction lines, then those are sloped often towards the compressor to allow gravity to help us get oil back. So we really use all three of these to get the oil that's leaving the compressor to come back to the compressor through the piping. If oil is to get trapped into a liquid receiver, so in this slide here, I show a liquid receiver, and you can see that there's a dip tube on the outlet of that receiver. And that dip tube extends down into the liquid refrigerant. And what I'm showing on the right side of the screen is a little snapshot of the liquid refrigerant and then the oil. And if you do not have mixing of the liquid and the refrigerant and the oil, you can get a film of oil floating on top of the refrigerant in the receiver. And you can see that dip tube would go down through that oil film and just pick the liquid refrigerant up and not carry the oil back through the system. So this is why we want there to be miscibility, mixing between the refrigerant and the oil. And if you do have any issues where you have a system where you're not getting good oil return, and you do have mineral alkyl benzene oil with it, and even an alternative refrigerant that's meant for those, adding a little bit of POE oil to the system, believe it or not, may help in the mixing and may help carry that mineral and alkyl benzene oil back to the compressors. So just a little note there if you're running into that situation with any equipment. So because of this challenge with the receivers, this is why we feel that systems that have liquid receivers in them, we feel more comfortable with an HFC refrigerant that works with POE oil, just to make sure we can get the oil out of that receiver. So let's move on and talk for a minute about pressure and temperature comparisons. So if we talk about the how the pressures compare between refrigerants, and particularly to R-22, you can see I have a little table up there with at 40-degree evaporating, I've got R-22 runs about 69 PSIG. If I were to have 407A in this system, I would be running about 75. Based on the average evaporator temperature, about 75 pounds of pressure. Or if I use 422B, I might be running about 64 pounds of pressure. And for a TXV, this is really not a problem. So long as the PT curve between these refrigerants are close, it's good enough. That spring in the bottom of an expansion valve, in many cases is adjustable, and you can dial in your superheat setting if you need to. Now, keep in mind that the bulb and the power head on the expansion valve may be designed for R-22. It's going to put out a pressure, which is an opening pressure for that valve, which is designed based on R-22 pressure. So you do want to be close. And if it's within 5-7 psi of R-22, usually you can just make an adjustment to the expansion valve and it should work fine. Now, when it comes to compressors, the reason I mention this is that if you pick an alternative refrigerant that's running lower suction pressure than R-22 did, typically that means that the density of the gas will be lower entering the compressor. And compressors just pump a certain volume. They pump a CFM. So if I have less dense gas, I'm pumping less pounds per minute of the actual mass flow of the refrigerant. So with lower pressure refrigerants, you do typically see lower net cooling capacity. So the BTUs that you're getting out of your system may be reduced when you go to a lower pressure refrigerant. That's important, because there are some refrigerants making claims about lower energy use than R-22. And R-22 is a very good efficient refrigerant, and they may have less amp draw on the compressor because they have less mass flow and the compressor is doing less work, not necessarily that you're getting better energy efficiency ratios with the amount of work versus the amount of energy. So just keep that in mind. It doesn't mean that we can't use a lower pressure refrigerant like 422B successfully. It just means you might see a little bit lower compressor capacity. So with these factors in mind, thinking about PT matches and all the things that I've mentioned up to this point, United Refrigeration and National Refrigerants feels that these three, 407C, which is the, I'll explain in the next slide, but 407C, 422B, or 422D, we feel are the best choices for your conversion gases to move away from R-22. And to get in a little bit into the air conditioning application and some specifics on each one, 407C does run lower discharge temperatures than R-22, but it has the best capacity match to R-22. If you go with 407C, you'll likely see no drop off in the capacity of your system. The BTU capacity will be very, very good. It has very similar pressure to temperature and mass flow characteristics. So we've had very good luck with it. We don't have component changes, existing expansion valves, so long as they were correctly sized for R-22, should work well with 407C. But again, 407C is an HFC, and it will require that you have POE oil in the system. Now, for systems where we are going to stay with mineral oil or alkylbenzene oil, we're recommending R-422B or R-422D. And again, these have a little lower discharge temperatures than 22. But as I mentioned in the previous slides, you will see some capacity drop because these do have some additives in them that help get that oil to circulate through the system. So you see a little bit less capacity drop. Now, to put this in relative terms, let's say you had an air conditioning system that ran 30 minutes of every hour. When you convert that system, you might see that system run 33 minutes or 34 minutes of every hour. And of course, it depends on how hot it is outside and what the head pressure is on the system. So, do you have an extra 3 to 5 minutes of runtime available in that system per hour? If you do, then most likely you'll see no issues whatsoever. If you had an R-22 system that was running max capacity and it never cycled off, then it may not be a good candidate for these, and you might want to go to 407C so that you maintain capacity of that system. And for expansion valve sizing, again, and component sizing, as long as it was sized with R-22 properly, then you should see it work well. If you had a marginally sized R-22, in other words, it's borderline too small with R-22, you may need to upsize the expansion valve. But that's something that if you need help with, United can help you with expansion valve selections. And then the final thing I'll mention is price. So as you can see on the chart here, I've got dollar signs for price. And relative to R-22, these three are a fraction of the cost of R-22. So again, there is a definite economic driver to moving towards these alternatives. When it comes to refrigeration, these three refrigerants are the ones that we recommend for conversions from R-22. That's R-407A, R-448A, and R-449A. And these three refrigerants perform very, very similarly. So really, I like to say that 448A and 449A are lower GWP versions of 407A. So, when you look at the pressure and temperature characteristics, very similar to R-22 and very similar to each other. They all have lower discharge temperatures than R-22, a fair amount lower than R-22, in fact. R-22 components will work with these refrigerants. These are all HFCs, and then in the case of 448 and 449, they have some HFO in them, and they are lower GWP gases because they have the HFO. Again, we've seen a lot of conversions. We've seen 407A be a very dominant player in the conversion business for supermarkets. And now we're starting to see that shift just because of GWP. Some customers have decided that they want to move towards 448 or 449. As Joe mentioned earlier in the slides, we have the AMAC coming, so customers are making decisions accordingly. And again, relativity on price, you're going to see these dollar signs over here on the left side, the right side of the screen. And relative to 22, they're all much less expensive, but 448 and 449 are more expensive at this point than 407A is. So again, there's a decision you have to make on cost versus GWP. Performance will be very similar with all three. So let's talk about the steps to retrofit a system. So the first step should be to do a survey of your system and collect the baseline data. So if the system is running, you're able to go through and collect pressures and temperatures. And in our retrofit guidebook, we have some survey forms in there and some ideas on collecting that information. So if your system's not running, obviously it'd be a little bit tough to collect the baseline data. Then you want to perform a thorough leak check. So you want to make sure that before you convert the system, you don't have leaks. So doing a good thorough leak check is the right thing to do. You would then, of course, if there's any refrigerant still in the system, you'd recover that existing R-22 from the system. Then you would perform service, repair the leaks, and replace the elastomers. So I'm going to explain what elastomers are and why they need to be replaced in the coming slides. Then you would go ahead and replace the oil. And, again, if you're sticking with a system that is compatible with mineral or alkyl benzene oil, then you may not need to do that. But if you're going to a system that's with an HFC, then you would replace to POE oil at that point. Then you're going to pressurize, leak check the system, and then ultimately do a good evacuation and pull a good deep vacuum on the system. Many contractors like to do triple evacuation just to make sure that the systems are good and tight and there's no non-condensables left in the systems. You'll then recharge the system, run the system and compare to your baseline data. And then step 9, extremely important, please label the system. So we are seeing mixed refrigerants out there coming back, and we don't know if it's just because someone didn't know whether the system had been converted or why we're seeing so much mixed refrigerant out there. But labeling the system with what the new oil type is and the refrigerant that's in the system is doing yourself and others a big favor, and it's the right thing to do for your equipment owners. So let's talk about leaks for a minute and those elastomers. So when we look at Schrader valves, of course, are great for accessing systems and make it very easy to put your gauges on and to get access to the refrigerant inside the system. But Schrader valves can be a major source of refrigerant leaks. And when you do a conversion, every Schrader core that's in that system must be changed. And I'll explain why that is here in the coming slide, but there are these elastomeric seals, which are neoprenes or rubbers that are on a Schrader core, and those can leak after a conversion. And I will also mention that there's many different types of Schrader valves. They can be for air, they can be for car tires, for all kinds of different applications. There's Schrader valves made. So we need to make sure that you're only using HVAC R type Schraders. So go to United Refrigeration, and that's what we carry, are only the Schrader cores for HVAC R systems, because the elastomeric seals must be compatible for the refrigerants. So elastomeric seals will swell when they get exposed to R-22. They do absorb R-22, and it depends on the type of seal. It depends on, there's 500 different compounds of these elastomers that get used in our industry, and some swell more than others. And so it's important for everyone to understand what causes the leaks or what causes the swell is not the oil, it's not the POE oil, it is the R-22 that's getting into the seals and then comes out of the seal. So I have this short minute long video I'm going to play that goes through, and I think is a visual. This video has been out for a long time, so it's not super quality, but it does really give you a good visual of what happens when the seals absorb the R-22 and then when the R-22 comes out. So I will go ahead and play that.
Here we have a new boot out of the compressor. I'm going to place next to it a boot that has been exposed to R-22 for approximately 24 hours. As we can see the R-22 begin to escape, causing bubbles and blistering of the surface of the boot. You can see how much it has swelled from absorbing the R-22. As we watch and listen, we can see the bubbles form and burst on the surface of the boot. The R-22 turns to gas and escapes.
Okay, so that video is a good visualization of just kind of why we recommend the seals be changed, because that seal will swell with the R-22, and the swell characteristics are different depending on what type of refrigerant and the type of seal that's there. So again, just a good idea to replace those seals, and that's why we recommend it. Of course, this seal that's in the video is a shaft seal for a open drive compressor, so it would not normally be in a hermetic or semi-hermetic compressor. But if you had an open drive compressor, certainly a shaft seal would be one that you would be concerned with. And then most of the rest of the seals are going to be in, in valves of some type. So when you go to charge a system with blends, then it's important to know that when you have a blended refrigerant, you want to remove that refrigerant or charge it as a liquid. So you would turn that cylinder upside down and charge as a liquid, because we want to make sure the composition is correct as it goes in the system. And that vapor on top of the cylinder has a different composition potentially than the liquid does. And so we always charge as a liquid with a blended refrigerant. So anything that's a 400 series refrigerant is a blend. that has some, temperature glide to it. So you want to charge that as a liquid. Typically, the density is a little bit lower with these alternatives than R-22. So you're going to go back with about 90 to 95%. And then you're going to charge these, if it's a fixed orifice, you're going to charge it by superheat. Or if you have a TXV in the system, then you would charge by subcooling as you normally would, and go back to the original superheat or subcooling. When you convert these systems with an orifice, if it's 407C that you're using, the orifice, you'll be able to go back and probably get the superheat dialed in pretty close to the R-22 with a very similar charge. If you're using 422D or 422B, it may take just a little bit more refrigerant to get the proper superheat to feed through that orifice. That orifice may be a little bit smaller than it would have been with R-22. So your choices are really either A, go find out the right orifice, B, convert the system to an expansion valve, or C, add just a little bit more refrigerant to get that superheat to where you need it to be. And so you might run a slightly higher, head pressure with that when you do it that way, but you should be able to get that charge dialed in. When it comes to leaks with the alternative refrigerants, if the alternative refrigerant has a temperature glide to it, which all these 400 series do, and you have a system that sits off for long periods of time. So say a system that sits off all winter and you leak during the winter, there is a potential for the composition of the refrigerant to shift. And so if you have if you've leaked more than about 50% of the charge, you would need to pull the whole charge, recover it, and then recharge the system. If it is a refrigeration system or a system that runs, doesn't sit for long periods of time, for weeks or months off, then you won't see any composition shift. So, that wouldn't be required to pull the whole charge, but it is something to keep in mind for, say, an air conditioning system that might sit off during the winter and, you leak the whole charge or more than 50% of the charge. Let's talk for a minute about superheat and subcooling. I mentioned charging that way. And since these new refrigerants have some temperature glide, it is important to understand how to properly measure superheat subcooling. So National Refrigerants has put out this really nice PT app. It's available for Android or for Apple. You can go to the stores there and download those for free. And this PT app will properly make sure you're using the right numbers when you do your calculation for superheat and subcooling. So over here on the left side of the screen is the input screen when you go to the app. And one of the nice things about this is if you have GPS enabled, it will automatically tell what your altitude is and adjust the pressures for your altitude. So if you're operating in Colorado or somewhere at high altitude, you don't have to have that, you don't have to type in the altitude. Now, if you don't have GPS enabled, you'd have to put in your altitude to get it to shift the PT curve, but it's pretty slick because it does that. So if you want to do it as superheat calculation, you just go in and measure your evaporator pressure and put that in this case, 45 PSIG. You'd enter the line temperature. So on the suction line where you want to measure the superheat, you enter the temperature of that line. And when you scroll down in the app, it's going to pull up this really neat graphic, which is going to show you the evaporator coil. And it's going to show you the X, of course, is the expansion device. And then it'll show you the temperatures that you would expect to see as the temperature glides and changes through the coil. And so you're going to get to this point where you have the dew point, and that's where you're going to measure your superheat from. So to do a superheat calculation, we would take the line temperature that you measured with your thermometer, and then you would subtract that from the dew point. And of course, the app knows you're doing superheat, so it automatically selects dew point. And then it will tell you what the superheat is, in this case, 7.9 degrees. And one of the also neat things is it tells you what the average coil temperature is. So sometimes you'll hear some in the industry talk about average or mean temperature of a coil. And this is really the only place I know where you can go to an app and actually calculate what that is. And of course, it's an approximation. It might be off a degree or so because we're making some assumptions, but it is a pretty neat way to see the temperature glide through a coil. When it comes to subcooling, we're going to do the same thing. We're going to enter in our pressure. In this case, it's our high side pressure, 240 PSIG. we can enter in a line temperature where we want to measure the subcooling. And again, the app will pull up this graphic. Now, in this time, the graphic's changed. It's a condenser, not a evaporator. And what you'll see is that the liquid, the dark blue is where the liquid is actually condensed. And so when we do our subcooling calculation, we would take the bubble point, or the point where the last bit of vapor has disappeared and now you're 100% liquid, and you take that temperature minus the line temperature you measure again with the thermometer, and that tells you that the subcooling in this condenser is 10.5 degrees. So again, we think this is a really slick app. It's got a large number of refrigerants it works for. So please go out to the App Store or Google Play and download it, and tell us what you think of it. Okay, one other application I want to mention here, and that is flooded systems. So we probably have some that are on the line here with us that work on some industrial systems, maybe even an ice rink like the one in the picture here. And flooded systems present a bit of a challenge for these blended alternative refrigerants, because a flooded system, you have a vessel or a liquid level in the evaporator, and the refrigerant is not turbulent. It just kind of sits and evaporates out of this vessel. And because of that, you have the potential for separation of these components in the blended refrigerants. So alternatives that have no temperature glide, that are what we call azeotropes, those are what we would recommend for an R-22 flooded system if you wanted to convert. So that really narrows our lists of available alternatives if we take that, if we stick with azeotropes. And maybe there's some others that have had good luck with some other blended refrigerants, but I'm just passing along what we've heard from the field. And we do know that 507 has been used successfully. It is an azeotrope. It's a blend, but it's an azeotrope. That's why it's a 500 series, because it does not have temperature glide. You will see a higher mass flow rate. So you'll see, pipe sizing or expansion device sizing might need to be addressed. And of course, it requires polyester oil because it's an HFC. But you'll have good capacity and good luck. Some of the lower pressure refrigerants, while they might work, the problem is that you would lose a lot of capacity, and your pipe sizing might be a bit of an issue. So perhaps this is a way to look at an alternative to R-22. Now, I want to point out that 507 is a higher GWP gas. So it is one that, with the AIM Act that and the HFC phase down that Joe mentioned, you got to consider that. And maybe this is just a refrigerant you can use to bridge the gap between the time when, the end user may be looking at a new system and they want to convert to 507 to get them out of 22. It might be that they can't go to 507 and they may need to keep that flooded evaporator system in R-22. So that would be one of these systems that are more complex and more costly to convert. But for flooded evaporators, that this really is a case. Now, I will also mention that it is legal to convert an R-22 flooded system in an ice rink or an industrial application. The SNAP rules we covered earlier do not prohibit this conversion. They do prohibit 507 in other applications like supermarkets or remote condensing units or standalone self-contained equipment. But for this particular application, it would still be allowable under the SNAP rules. Okay, and then finally here, getting towards the end, we do have some resources out there for you at uri.com. So we've put the retrofit handbooks and a conversion survey form. We have this really nice publication from Sporlan on how to get the seals that you would need to replace the elastomers that are in their valves and components, which again covers a lot of the elastomers that would need to be changed. We've uploaded that replacement parts guide out there. And again, you just go to our website and then go to the R-22 Information Center, and then you can click through the different pages there and go to resources and downloads to find some of this additional information. Okay, and with that, I'm going to turn it back over to Joe where he can kind of wrap us up, and then we'll go into the Q&A portion.
Thank you, Russ. I appreciate it. So in summary, R-22 supply truly is limited and demand remains strong at this point. It really is imperative that systems are converted to be sure the product is available for the foreseeable future, right? So we want to encourage folks as much as possible to move over to these alternatives and to feel comfortable when making the changes. And that's really the purpose of going through in as much detail as we have to make sure that we cover all of our bases and make sure that you feel comfortable when you're making these changes. So the preferred refrigerants on the refrigeration applications at this point are 407A, 448, and 449. And you would find that they are very well stocked out in the field and in stock at every United Refrigeration location. As for HVAC, I see 407C and 422B and D are definitely the recommended for HVAC applications. I did see one question come in about the difference between R-422B and R-422D. And just to clarify, it really is just a matter of composition. So originally, they were manufactured by two separate companies. 422B originally was manufactured by Icor, and 422D was originally manufactured by Honeywell. So both gases are a mixture of 125, 134A, and R600A, and they do have similar capacities. Basically, they were just manufactured by different companies originally. So hope that answers that question for anybody out there. And I'll just leave it with one point, that when you're considering retrofits or when you're performing retrofits out in the field, if you have a significant amount of R-22 that you recovered from the system, we might be interested in talking to you about potentially purchasing that gas in significant quantities. So if you come across a situation like that, please feel free to contact your local United Refrigeration branch, and they can talk to you about how to go through that process. So with that, Rob, I guess if there's any other questions, we can open it up for any questions at all.
Sure. Russ, I think you had a couple questions there that you were going to speak to.
Yeah, one of the ones that did come in, again, I saw one question in there that was about the orifice. Do I need to change an orifice when converting? And, I tried to cover that because, that's to determine the correct orifice that you would need on some existing system that might be a number of years old. If you can find that information, then great, you can convert it and change the orifice, but unlikely you would find that. So you're left with, you can get an expansion valve kit, and we do make expansion valves and sell them with, or we don't make them, we sell them with the right either Aeroquip or chatless fittings to mount onto that distributor inside that evaporator and the air handler to make it easier to adapt a system to go from an orifice to a thermostatic expansion valve. Or in many cases, you can adjust the refrigerant charge to get the proper superheat you need out of that coil, even if the orifice is a little bit on the small side. If it's much too small and your head pressure has to go high to get the superheat, then we would need to convert that to an expansion valve. One of the other questions that was asked was about oil filming. And so one of the interesting things about oil filming, certainly, if you do get foaming of oil in compressors, many times that's an indication you have liquid coming into the compressor. And but what you also see is that the amount of refrigerant that can be entrained in oil, that oil will absorb some refrigerant, and it varies depending on refrigerant type. So in some cases, mineral alkyl benzene oil can absorb more refrigerant than say a POE oil does. So you might get more foaming action depending on the type of oil, and that might be a result of just the type of oil you have, and then whether it's R-22 or what type of refrigerant. So I think if there's any specifics on that, let us know. We can maybe talk about a specific application if you want to reach out separately. But keep in mind that foaming is indicative of either refrigerant flow back coming back, or it's just maybe some refrigerant that's actually entrained into the oil. We particularly saw that on some supermarket systems where we had maybe a high pressure oil system, and we had an orifice which was going through a float just right on the compressor, where we went from high to low pressure without going through a receiver, oil receiver vessel first. And then that didn't, that outgassing of the refrigerant causes some foaming up of the oil, into the compressor. So again, we'd be happy to answer any specifics if you reach out separately. Okay, Rob, was there any others on here that you?
Yeah, just a couple. Could you speak to any warranty concerns with using some of the retrofit choices we talked about, compressor warranties?
Yeah, that's a very good question. So Copeland has a bulletin out. It's bulletin 93-11 that specifically lets you know the status of what refrigerants are approved for use in their compressors. And that's a really important, in fact, I think, Rob, what we should do is put that bulletin 93-11 for Copeland. We will put that bulletin up into the resource center under R-22 information. And then we'll see if we have any other manufacturers information out there. But they do a very good job of explaining what type of compressors and which, what refrigerants and oil combinations are approved and would be covered under the warranty in their compressors.
Okay. Just so everybody knows, we're right at the bottom of the hour here, 1 o'clock. So I'm just taking a look at the questions, but if anybody has to jump off, don't be afraid. Like I said, we'll post any of the questions that we get. If we don't get to these here, we'll post an FAQ on the R-22 Information Center as well. Solenoid valves, when would solenoid valves need to be replaced due to the seals of an old system?
Yeah, it's a great question. So the good thing is that the solenoid valves, the body of the valve should not need to be replaced. Certainly if it's a hermetic valve that can't be taken apart. So some of the very smallest direct acting valves, they do not have an external seal that you have to worry about. But if it is a take apart solenoid valve, and that take apart valve, you would need to replace the seal. So if it is, of a certain vintage, maybe the alternative seal is available. But if not, then you might have to convert that valve from, by style. So there is a kit that is available. One manufacturer, if you just take the Sporlan valve, for example, there is a kit that's just the enclosing tube itself that allows you to convert that to the new style seal. And so rather than buying the whole entire rebuild kit, which has a disc inside of it, is more expensive, we can supply just the enclosing tube kit, which allows you to convert that to the new style seal. So if you have an old valve, say a valve that was built from really about 2001 and prior, would be ones where you might need to convert the enclosing tube on say a Sporlan valve. So for other manufacturers' valves, then we'd have to go out and see if we can get the seal for that valve still, the replacement seal. And if we can't get the seal, then you might have to replace the valve. But again, that's where you just should work with your United Refrigeration. And we've got information by manufacturer that would be helpful. The other piece that I would mention would be that system survey sheet that we have on our website. Is a good thing to have, where you can go out and kind of go through a system and write down what valves you have in the system, and then write down the date codes. So really important to get the model number, but also the date code, because if a valve was built, in 2005, for example, probably doesn't need to have the seal replaced, because that might be the new style seal that is not an elastomer, and we can help you identify that. So, again, use some of those resources.
Question about a specific application, a couple of them. One being refrigerated milk tanks, asking if they should go 407C or 407A. We might need to get more information on that.
Yeah, I think that probably probably what we'll do is we'll try to gather some information on the milk tanks. What I don't know in those applications is really if those are considered, would be considered DX tanks, not flooded tanks. They're probably DX tanks, but it might be good to reach out to the manufacturer of that milk tank, because there might be some characteristics of their evaporators that I'm just not familiar with. So we may reach out to a dairy tank manufacturer and get their opinion on that. And if we do, we can post that in the FAQs.
We're about 5 minutes over here, so we'll make this the last one. Recommendations on changing out the dryer when swapping out refrigerant.
Yeah, that's a great question. The dryer should absolutely be changed. So when you get into a system, and you're changing refrigerants, you're pulling vacuums, you're charging with a new refrigerant, that filter dryer is chief insurance policy. And I would expect that the gas that you're going to get, wouldn't have any issues, but you don't know. You just don't know, if there's something that was in your hoses, or just whatever it might be. The system performs with that new refrigerant in it. Particularly, if you convert that refrigerant to POE oil. POE oil can act as kind of a solvent. It will go out and kind of clean the inside of the system and pick it up and circulate debris. And your insurance policy, to make sure you don't plug up a expansion valve or expansion device, is to put a good quality filter dryer in front of the expansion device. So I would absolutely change that when you do a conversion.
Sorry, my type. Just, I guess we'll give it this one last one, because I just want to, there was a question about an A3 R-290 being used in 22 systems, so figure you might want to.
Yeah, absolutely not. Do not use any type of a hydrocarbon. That is illegal to convert a system from R-22 to R-290 or any hydrocarbon. It's a very dangerous situation. So only systems that would have been designed for R-290 would be allowed with that. And the charge limit on R-290 right now is 150 grams. That's about 5 ounces of refrigerant. So again, there's a lot happening in the alternatives for new equipment with R-290, but those charge limits currently apply. They're maybe going to go up on charge limits for self-contained equipment, but maybe we go from 5 ounces to 10 ounces, or something, maybe somewhere around that. But it's certainly not going to be 5 pounds of R-290 or anything like that. So again, please don't convert an R-22 system to a hydrocarbon in R-290.
Okay. I think that's the time we had for questions today. Like I said, if anything else comes in here, if I missed anything, we will make sure to review the chat afterwards, and we'll go ahead and put it in the FAQ, which again will be posted on uri.com and the R22 Information Center. I posted links to both places, to that as well as our YouTube channel. We will have to probably, it might take a day or two to get the recording cleaned up and posted to the YouTube channel, but we will get that up there for your review, so that you can go back and watch this with anything you missed. So with that, Russ and Joe, I'll let you close it out, and thank you for attending.
Yep, thanks, Rob. And I'd just like to say again, thank everyone for attending. I think, great questions, and, again, please reach out to any of us, to United or National, if you have further questions that we don't get answered in our FAQs. Thanks again for attending.